Hi and good day everyone. My name is Viknesh Armukam. My metric number is 186952. In this video, I will explain about the final year project ECH 49498, section 2019-20, Bachelor of Chemical and Environmental Engineering, University Putra, Malaysia. My supervisor is Dr. Muhammad Haikal Ismail. In this video, I will explain about research background, problem statement, objective, and methodology. And my FYP topic will be synthesizing green Chitosan-Magnetite composite particles from prawn shell for effective palm oil in effluent POME pretreatment. Palm oil industry growing rapidly. However, with quick development of palm oil industry, it has gone through the environmental challenges, which have serious consequences on the natural environment. Therefore, the pretreatment of POME using coagulation and flocculation process by recycling and utilizing back the prawn shell waste, which means in this study the prawn shell waste will be utilized back to create a product in order to reduce the environmental pollution. The process flow will be started with prawn shell waste. Later on, the chitosan will be extracted out from the prawn shell waste, then cross-linked together with magnetic particle to produce the Chitosan-Magnetite composite particles. These composite particles act as coagulant. This coagulant will be used to treat the POME. The coagulant will be absorb all the suspended solid together, and at last, water and suspended solid is remain. The water will be recycled back or recovered back in the process. Research background of POME. Acidic in nature. POME has high BOD and COD level. Biological oxygen demand is around 25,000 mg per liter, whereas chemical oxygen demand is 40,000 mg per liter. POME can create serious consequences on the natural environment. Traditionally, we are using a pond system to treat the POME, which is the aerobic and anaerobic process. But this system is required a large area and have a high demand of maintenance. At the same time, large amount of greenhouse gases will be emitted to the atmosphere. So the better choice will be coagulation and flocculation process to treat the POME, because the coagulant is environmental friendly and can easily recover or recycle back the water. Second will be the prawn shell waste, chitosan. Chitosan is a biodegradable and non-toxic. At the same time, it can increase the treatment efficiency. Chitosan is a cellulose-like biopolymer which has been extracted from prawn shell waste via three processes: deproteination, demineralization, and deacetylation. Chitosan can have a high capacity of absorbent and is an environmental benign product. So from the prawn shell, we are creating a chitosan. So which means from a waste, we are creating a product. So overall, is showing that we are implement the aspect waste to wealth. Magnetic particle, iron oxide. Iron oxides have a high ratio of surface to volume because naturally it will produce in nano size. Magnetic particles have a higher absorption capacity and can absorb the contaminants from effluent. It can be prepared by co-precipitation method between iron to sulfate and iron to chloride, and can be separated easily by simple magnetic process. Let me show how the simple magnetic process working. So the magnetic particles will be attracted with magnets. So this is one of the way, or this is the how we can say the simple magnetic process working. The last will be Chitosan-Magnetite composite particles. These composite particles has been created by cross-linked together between the chitosan and magnetic particles together to meet the needs of high absorption, self-regeneration, and cost-effective wastewater treatment. Can be prepared by co-precipitation method as well and easily separate by simple magnetic method. It has believed that these composite particles can enhance the performance of agglomeration. Problem statement. POME. Treatment of POME is a challenging task for environmental engineers. Therefore, pre-treatment POME using coagulation and flocculation process has become an important feature. Prawn shell waste. Prawn shell waste produced in large quantities, especially in Southeast Asia. So this is one of the beneficial to extract the chitosan in large quantity. Then the chitosan will be used to modify by cross-linking with magnetic particle to create the chitosan-magnetite composite particle. Because you have a high, you can increase the absorption of contaminants from effluent. Objective: first will be to synthesize chitosan-magnetite composite particle from Prawn Shell waste. Second will be to analyze the wastewater quality during startup and end-up period, which means we will compare the wastewater quality before and after adding the coagulant. Last will be to obtain the optimum dosage of coagulant needed to achieve maximum reduction in wastewater parameter. The wastewater parameter will be chemical oxygen demand (COD), turbidity, and pH level. Our composite particles can create a greener energy, develop waste management system, act as a useful biomaterial, sustainable, can create a POME wastewater treatment, and also can minimize waste generation. Methodology. In this aspect, we have three main parts. First will be the extraction of chitosan, followed by synthesizing of chitosan-magnetite composite particle. At last will be analytical method. Extraction of chitosan. First step will be deproteination, where we are using a low molarity of sodium hydroxide. This process because we are removing the protein, the tertiary structure of the cell. Followed by the demineralization, we are using slightly concentrated hydrochloric acid, which is 1.5. This step where we remove the minerals, or specifically we can say inorganic components such as calcium carbonate. And last step will be deacetylization, where we are using high concentrated sodium hydroxide 35%, where we are removing the acetyl group and resulting in the formation of amino group. The chitosan that has been extracted have a moisture content between 5 to 7, pH value 7 to 8, color will be pale pink or milky white. This depends on the depigmentation process. If the extraction process further up with depigmentation, the chitosan will be milky white in color. Solubility in 1% of acetic acid is 99.5%. Synthesizing chitosan-magnetic composite particles. This one method will be begin up with a two solution, which is a iron 3 sulfate and iron 3 chloride and iron 2 sulfate by using molar ratio 1 to 2, and this solution will be mixed up together with chitosan solution. The chitosan solution means the chitosan has been dissolved in water, and this three solution has been mixed up and start up the co-precipitation process by adding a sodium hydroxide dropwise. And the end of the product, end of the method or end of the experiment, we get the product. So the first picture shows that we are mixing up all three the solution: chitosan, iron 2 sulfate, and iron 3 chloride. The second picture showing that we are adding sodium hydroxide dropwise. That's why there's a small black particles form. At last, after we add on all the sodium hydroxide, the chitosan-magnetic composite particles has been formed. That's why the solution itself is black in color. Analytical method. Analytical method will start up with pH level, where we are measure the hydrogen ion concentration of the solution. Then turbidity. We check the cloudiness of water caused by suspended solid. At last will be COD, chemical oxygen demand level. Measure the oxygen level required to oxidize organic matter in water. So the pH level should be neutral, the turbidity level should be low, and the COD level should be low by using the same amount of composite particles. So this is showing that the maximum reduction of the treatment. So when we achieve the maximum reduction by using the same amount of composite particle, by achieving all these three criteria, pH level, turbidity, and COD, then that's showing that our treatment process is success. At last, we can say utilize the prawn shell waste to create a green product from prawn shell waste to chitosan. The product itself, the composite particles, can enhance the efficiency in agglomeration and adsorption, followed by coagulation and percolation. Environmental friendly pretreatment techniques, because we are using natural environmental benign products, so it can create environmental friendly pretreatment technique. And identifying maximum reduction in the parameter of POME. Chitosan-magnetic composite particles are the better choice to use as a coagulant. This is because magnetic particles are higher in adsorption capacity and helps to remove the contaminants from aqueous effluent. That's all from me. Thank you so much for lending your ears.